When working through a question with multiple parts, we will usually need our answers for one part to help us find the answers for another. So instead of flipping through pages trying to find previous answers, it is always a good idea to write the information you have found directly on your diagram. In this case, we have just found that ABC is an isosceles triangle because side A is equal to side B. To show this on the diagram, you can put a small line on side AB and again on side BC. This indicates that the length of these two sides are equal. And now we can move on to part C. Determine the coordinates of M, the midpoint of AC. To find the midpoint, we can use the midpoint formula, where M is equal to x1 plus x2 over 2 for the x-coordinate, and for the y-coordinate, y1 plus y2 divided by 2. We're looking at the midpoint between A and C. So let's say that A is our first point and C is our second. Now we can fill in these values into the formula. So we can say the midpoint M is equal to the x-coordinate of A, 1, plus the x-coordinate of C, 6, all over 2. For the y-coordinate, we use the y-coordinate of A, 3, plus the y-coordinate of C, 4, all over 2. We can put this into a bracket. Now we can simplify our fractions. 1 plus 6 gives us 7 over 2, and 3 plus 4 is also 7 over 2. So these are the coordinates of midpoint M. Part D says determine the gradient of line AB. To determine the gradient, we need to use the gradient formula. M is equal to y2 minus y1 over x2 minus x1. We want to find the gradient of side AB. So let's make A our first point and B our second. Now we can say M, the gradient of AB, is equal to the y-coordinate of B, 1, minus the y-coordinate of A, 3, over the x-coordinate of B, 4, minus the x-coordinate of A, which is 1. 1 minus 3 gives us negative 2 over 4 minus 1, which is 3. This is the gradient of line AB. And finally, we can move on to part E. Show that D, with coordinates 7, negative 1, lies on the line that goes through AB. To show that a given point lies on a line, we first have to find the equation of that line. The equation of any straight line takes on the form y is equal to mx plus c. From our work with straight lines, we know that the value of m is the gradient of the line. And in part D of this question, we found the gradient of AB to be negative 2 over 3. So we can start by writing the equation for this line as y is equal to m negative 2 over 3 x plus c. Now we have our m value, but we still need to find c. To find c, we substitute the coordinates of a point that we know lies on the line into the x and y values of the equation. Let's use point A. We can say the y coordinate of point A, which is 3, is equal to m negative 2 over 3 multiplied by the x coordinate 1 plus c. Now we have 3. Negative 2 over 3 multiplied by 1 is negative 2 over 3. Let's move that to the left and we get positive 2 over 3. And we make this equal to c. Now we need to add these fractions. So let's turn 3 into a fraction with a denominator of 3. And we get 9 over 3 plus 2 over 3 is equal to C. 9 plus 2 is 11. So we get 11 over 3, which is equal to C. If C is 11 over 3, then we can write this equation as y is equal to m negative 2 over 3 x plus c, which we now know is 11 over 3. Now, in most of the examples we have looked at in this course, we have found c to be a whole number. So before we move on, let's double check that this equation is correct. We know that point B with coordinates 4, 1 also lies on AB. So if we substitute the x coordinate of B into the equation, we should find the value of y to be the y coordinate of B. B has an x coordinate of 4, so we can say y is equal to negative 2 over 3 multiplied by the x coordinate 4 plus 11 over 3. Now we can solve for y in hopes that y will be the y coordinate of B. So we can say y is equal to negative 2 multiplied by 4 gives us negative 8 over 3 plus 11 over 3. Negative 8 plus 11 gives us positive 3 over 3, which is equal to positive 1. Our y value is 1. It is also the y coordinate of B, so we know the equation is correct. Now we can focus on point D, so let's make some space. To prove that point D lies on line AB, we need to substitute the x coordinate into x in the equation and show that y is equal to the y coordinate of point D. The x coordinate is 7, so we can say y is equal to negative 2 over 3 multiplied by 7 plus 11 over 3. Now we can say y is equal to negative 2 multiplied by 7, which gives us negative 14 over 3 plus 11 over 3. Negative 14 plus 11 gives us negative 3. So we get a fraction of negative 3 over 3. Now 3's will cancel and we're left with negative 1. Y is also the y coordinate of D. So as our final answer, we can simply say D is a point on line AB. Let's do another example.